Hello, back again with อาจารย์ปัด Patamaporn. You can call me Pat for short. Okay. We're going to do mesh analysis and super mesh in this video clip. Okay. So mesh analysis is another method to analyze your circuit. Okay. Sometimes it's called loop analysis, but I like to say mesh. Okay. And if you remember the difference between mesh and loop, okay, what it is, okay, you go and find out from the previous video. Okay. So there's a method again, just like nodal analysis. There's a steps that you can follow to do it. Okay. So the first one is, okay, let's write down the steps first. So define each mesh current consistently. Normally, please do it clockwise. Okay, I like things clockwise. Okay, and my solution is always clockwise in the exams, so therefore it's easier for me to grade in a way. Okay, when you make a mistake, your answer is not the same as mine, so I would go back and see where you got it wrong, and please help me. Try do it clockwise directions. Okay, from the current directions in each mesh. Okay, from the current direction in each mesh, define the voltage polarity, okay, as in current enter the positive terminal of the voltage drops. Okay. Step 3, apply KVL around each mesh. Okay. If you do mesh 1, current I1, just write down KVL I1. You go to the next mesh I2, write down KVL for mesh I2. Okay. Then you express the voltage. You get, you do KVL, right? So you add voltages. Well, but we want to change those voltage terms in terms of mesh currents. Okay. And then you solve for the mesh currents. So in a way, mesh analysis, your answer would be the current. The mesh currents would be your answers. Okay. So therefore, well, let's look, okay, step by steps. Same, if you realize we have the same example, same circuit problems that I just did with nodal analysis, and now we're doing it mesh analysis. Okay, so therefore we are given VS1, VS2, okay, R1, R2, and R3, and we want to use mesh analysis to find mesh currents. So as you can see, right, mesh, right, so we have two meshes here. So I1, please clockwise directions that you can see consistently, say both clockwise directions. Right, so assign the name I1, I2. Then second step, right, so this is what I did, right, so mesh clockwise direction, right, then from the current direction in each mesh, identify voltage drops, so it becomes the red color. Okay, let me look at, let me do this, hold on, take the blue one out first. So I'm in the blue mesh, right, blue mesh. So therefore, current I1 goes like this, okay, go like this, right, I1, okay, but it enters R1, right, so you have plus minus VR1 like this, let's say, okay, then with this blue color I1, it goes to R2, so I give you plus minus VR2 like this, okay, VR2, right, then it said write KVL for mesh I1. So KVL add voltages. So let's start with, I'm walking from here, right, with I1. So plus VR1, see positive sign first. So plus VR2, right, come back here, see negative sign, so minus VS1. Okay, right, then it says express, then you have, this is KVL, correct, right, for this mesh I1. Right, mesh I1. Okay, then express it in terms of the mesh current. So look at V equal to IR, right? V equal to R times I, Ohm's law. So VR1 is R1 times I1 because I1 passed through R1. So R1 times I1. R2, we dropped VR2, right? R2 times the current that's going through R2. Well, the current I1 go into the, we are here, right? We use this blue color polarity. So I1 enter the positive, so positive I1, right? But I2 enter the negative, I2 negative, so minus I2. Okay, so the current going through R2 is a share between, they're both I1 and I2, but which directions? Okay, you have to make sure that you got the direction correct. Okay, so in this case, you look at the blue color VR2, right? So I1 enter the positive, so positive I1, I2 enter the negative, so minus I2. Okay, then you get minus VS1. Okay, so therefore you have, you factor together, you get R1 plus R2 I1 plus R2 times minus I2 equal to S1. So you get your first equations. Okay, so you have it in terms of the mesh currents. Now I2, let's use pink color. So I2, right? I2 still clockwise directions. Okay, so as I2 enters R3, so you have positive, negative, right? VR3, right? Comes here, well, it would be positive, pink, we are pink now, minus, let's call it VR2 prime, okay? So therefore, write KVL. So KVL would be, if I start walking from here, go along with current I2. So you see positive VR3, right? See positive VS2, and then see positive VR2 prime. Okay, VR2 prime. Okay, pink, right? You're in pink color. Change it into mesh current. So VR3, well, I2 pass through here. So VR3 is R3 times I2, right? Now, VR2 prime, right here, VR2 prime. Well, it's R2 multiplied by the current going through R2. Well, there are I1 and I2 going through R2, but which directions? You are in a pink one, right? You're in a pink mesh right now. So you see I2 enter the positive, right, side of VR2 prime. So positive I2. And I1 enters the negative side of VR2 prime. So therefore, minus I1. Okay. So therefore, VR2 prime is R2 multiplied by R2 minus I1, right? And then you sort of like, make it, factor it together, and this is your second equations to solve the problems. And so using these two, you can solve for the mesh currents I1 and I2. See, as simple as that. So it's a mixture of KVL and Ohm's law. And for the nodal analysis, it was KCL and Ohm's law. Okay, so this is just put in the values in it. You can copy it, right, and try to do it by yourself. Okay, and so therefore you will get the answer using Kramer's rules, as you can see. Okay, Kramer's rule, and you get the answer I1 and I2. So please go and try to do it on your own, okay, using your calculator. Make it a practice to do it, okay, not just me telling you that, oh, it's this. Okay, so therefore this is the and as you can see, the answer I2 is negative minus 18.7 milliamps. So therefore, if you actually constructed these problems, okay, so your I1, right, your I1 would be 139 milliamp, would be like this, right? But I2 actually would go into the opposite direction, right? So the current would go like this, and then it come down like this. Okay, so therefore, with whatever you assigned, right, the answer would correct the actual direction of the current. Okay, so this is super mesh. So if you look at these problems here, okay, so let's try this one. Okay, we have two meshes again, right? So therefore, okay, clockwise directions, I1, I2, clockwise directions, okay, and then you write KVL for mesh 1, right? So mesh I1, okay, so you see it goes minus 10, right? Minus 10 is come here, right? Plus you can write it right away as 5I1. So we drop across 5 ohm is 5I1. And you see this is a independent source, so plus 9. So plus 9, right? And the voltage drop across the 10 ohms is 10 times, so I1 go into the positive of this side, I2 go into a negative, so I1 minus I2 equal to 0. Okay, so you get factor the I1 together, I2 together, and you get this is your first equations. 15 I1 minus 10 I2 equal to 1. Okay, then mesh I2, right? Look at mesh I2, right? Mesh I2, so KVL I2, right? It will be voltage drop across the 5 ohms plus 1 here, right? Plus 1 plus voltage drop another 5 ohms right here. Okay, then plus V drop across the 10 ohms. Then you see minus 9 equal to 0. Okay, V drop across R1, the first one here, right? This is I2 passing through it. So 5 I2 plus 1 plus this is also I2 passing through it. So 5 I2 plus 10 times what? I2 going, so we're now in a mesh, second mesh. So with according to I2, this is positive, this is negative. So it's I2, right? I1 go in the opposite direction, going to a negative sign of the voltage drops across 10 ohms. So minus I1, right? And then minus 9 equal to 0. So you get 5I2 plus 1 plus 5I2 plus 10I2 minus I1, right? Oh, I forgot minus 9 here. All right, minus 9 equal to 0. Okay, minus 9 equal to 0. So therefore, you get, this is your second equations. Okay, and using matrix, I use Cramer's rules, and you get I1 and I2. So I hope that it's very, from what I've seen my students, okay, it seems that mesh is very easy for everybody, and you guys would remember mesh the most, okay, how to use it. Okay, next one, okay, super mesh. We have super node, so it's only fair we have super mesh also. Okay, so the definition for super mesh is, okay, a super mesh results when two meshes have a dependent or independent current source in common. Okay, so two meshes that have current source in common. So let's look here. Okay, so this is an example of that. Okay, so this is, you have mesh 1 I1, right, and I2. I1 and I2, and between these two meshes it shares a current source, right? So therefore now you have a super mesh. So what it is that from the super mesh, right, super mesh, okay, the information that we can get out of super mesh in this picture is, of course, well I2 go into the same direction as 6 amps, right? I2 goes like this. So therefore, I2 is in the same direction as the current source, 6 amps. So you take the positive sign. So I2, so it's I2, okay, I2, okay. Whereas I1 goes in the opposite direction, so it's minus I1, okay. And between these two, right, well, it's equal to 6 amps, because if you think with 6 amps goes through this resistor, and the current going through resistors are I2 minus I1, so equal to 6 amps. Okay, if you're not so sure about that, you can think of, if you write KCL at this point here, A. If you write KCL at A, see A right here, right? I2 go like this, I2 going in, right? I1 is leaving, minus I1, right? 6 amp is leaving, so minus 6 equal to 0. So KCL at point A, at node A. So therefore you would get I2 minus I1 equal to 6. Okay, just like that. Same thing. Okay, so when you have a super mesh, this is information that you get, right? So there's no reason to write both KVL for I1 and I2, we write down the supermesh equations. So we write a KVL for the supermesh. Okay, the current I1, I2 is still there. Okay, it still pass through, I1 still pass through 6 ohms, I2 still pass through 10 ohm and 4 ohms. But the way we write KVL, we take the big loop. Okay, the big loop, so we have the loop. So therefore, supermesh loop, right? So it's a yellow loop, so minus 20, right? Go see minus 20, plus V across 6 ohm, this one, plus V across 10 ohms, plus V across 4 ohms equal to 0. Right? And then we change it to the mesh currents form, right? So V across 6 ohm is 6 I1 because I1 passed through here, 6 ohms. V across 10 ohms, 10 times I2 because I2 passed through 10 ohms, and 4 also, the current passed through 4 ohm is I2, so therefore it's 4 I2 as a voltage drop across 4 ohms. And so therefore, this is your, this is your first equations, right? You get it from supermesh, okay? And then, of course, you need, it's I1 and I2, two unknowns. You need two equations to solve for it. So another one is you get it from supermesh, which is I2 minus I1 equal to 6. So you get it from supermesh. So you use 1 and 2 to solve for I1 and I2. So use these two equations, solve for I1 and I2. So this is the idea of supermesh. Okay. So that's it for supermesh. Okay. All right. So quite easy, quite simple. Just need to do more exercise. Thank you. Bye.